Hello, my dear students, and I hope you are doing very well. Today, I'm going to give you another chapter via this video learning. Today, we are going to talk about a chapter of break-even point, sensitivity, and payback analysis. For the great importance that the market and the business and engineering as well are the most important things while we are doing the economic analysis and feasibility study. We have to know and to follow the tenders as you have in the assignment. We have to be aware about the pricing. The pricing is the most important things and it's the strategy. So we have to strategy. Today, we are going to take one of the tools that used to realize to the analysis the real cost pricing and the real pricing point. Through this analysis, we are going to find out the best pricing value, which depends on the how much is the cost is there and how much is the profit is there. So the point is to find the actual price that will cover this cost. That's called the break-even point. Also, we have to break-even point is used to find the sensitivity of the parameters that we have during the analysis of the projects, and the sensitivities are going to study the parameters that will be included in this analysis. Payback analysis is simply is to find the number of the periods, the number of the years that will cover at least the price and at least to cover the price and the years that used to cover the whole cost that used in this project. So break-even, sensitivity of the parameters, and the payback analysis are one chapter is very important to you as an engineer, and we have to be aware about in our engineering analysis and feasibility reports. So let's start with this one. As a definition of the break-even point, as we say, the break-even point is the value of the we are going to find a real pricing number, and the real pricing value for the units we are going to produce. Are here in this chapter are going to talk about projects that have produce units, or let's say like cement factories, like the project of producing gases and oil, and any projects that have productions. So the production is the number of the units that will be produced per year, per unit time. So only the numbers are, it's called the Q, and we have to find the best price to sell that number of the productions in a way that will cover the cost. This is called the break-even point. And after that break-even point, or the number of the productions that will cover only the cost, then there will be a profit area. The profit area will be belong after the price. After the price that is exactly called the break-even point. Break-even point, that's market values. So it's a market value that's covered the value of the parameters or the decision of the parameters. Examples, as I say, there's the example determining the required years. So here's the required years. We need to know how much is the years that's required to cover the initial investment and the annual operation of costs. Whenever you are going to take a project or you are going to establish an investment project, you have to be aware about you will not take the benefit in the starting. you have to wait for a little time, for let's say for a period of years, that maybe months, depends on the project. You have to wait, and you have to produce your units, and you have to make benefits, and already you are paid for the costs for the properties, you are paid for the advertisements, you are paying for the cost of the area and the land tasks. So you have to be aware that you are not taking the benefits in the first point of the work. Now this is called the fixed cost. So in the beginning you have to pay, you have to establish, you have to buy the machines, you have to buy everything that you need to produce the units. If you are going to produce, let's say, a factory of cement factory, so you have to first to buy the factory and to establish the factory and everything. So this is a cost. This cost is called fixed cost. Now after this, and after you are now ready to produce, you will start producing the units. Let's say ton of cement that you need to sell per one date, and produce and sell. So selling, producing is not that important, even if there is not selling. So you have to be aware, you have to sell. So as much as you have selling, you will get benefit from that production. And even if you have a selling for each ton of cement, let's say, or producing 1 barrel of oil or gas, petroleum, so per 1 barrel you will have a cost, a specific cost that will include the labors and the materials that's used to produce that unit. So basically we have a fixed cost that's dealing with each production. We have a production. The production, there is a selling price, you will sell that one, and for each unit there is a cost, there is a variable cost, there is a cost that used the people that's working for producing that unit, and the material that will involve in producing that unit. That's called the variable cost. And from this one and this one, you have to find out how much is the production will be needed to only just to cover the production, the cost, and to be now in safe side. And after that, so here's the very important break-even point. Okay. In economy, or in terms of economy, the break-even point can be found using this equation, taking the profits and the costs are equal. It means that how much is the present worth of the benefits are equal to present worth of the costs. In this time you will find the number or the price that's needed, or the, let's say, the production units that's needed to cover the cost only. This is in another term that means that you are taking I is equal to 0, or rate of return is equal to 0. The applications of rate of break-even point. Let's have a closer look for this graph. As I said, we have units, produced units, or let's say this is the units that we are going to resell it, or selling units. And here's there is 1, 2, and 3 relation between the units that will be produced and sold and the cost, whether we have revenue. This is the revenue, this is the cost. As we said, until you have a production, unless you have producing units, you will not get revenue. So if there is 0 production, there is 0 revenue, because there is nothing to sell. So that's why it's start from 0 point. and that's why we are starting from zero. This curve is linear. Sometimes how much if you sell 1 unit, let's say 1 barrel of the oil as $20 per $1, so the price will be, the revenue will be $20. If I sell 2 barrels, so 2 times 20 is equal to $40 is the revenue. Now, so it's a linear equation. As much as you have production, as much as you will get the same. So this is linear type of the relation between the revenue and the units. Sometimes in some productions you have not linear production, so sometimes that depends on the demand of the markets. So sometimes there is no linear relation between the revenue and the units. Okay, sometimes when you are producing more units, so the price will be fixed, or let's say the revenue will come down. It depends on the materials and the factories that you are working on. Also, this is related to the revenue in the relation of the cost. As we see, this line, as you can see, this is called fixed cost. Fixed cost, it means how much is the needed money to establish that project, from the land, from the properties, and from the advertisement, for the machines, for everything. So to establish this project, you need a fixed term amount of the money. Now after that, so we start from, not from zero, we start from what? From a certain amount. This is called initial investment. That's the P. And after that, there will be after, for producing each unit, let's say for producing each ton of cement, you need material, you need workers, you need laborers, you need electricity, you need fuel. So after that, as much as you have production, as much as you need more laborers, more peoples, more fuels. So that's called variable cost. And variable cost will start from zero, because unless you don't have any production, so there is no cost for laborers, there is no cost for so that's called zero. But as you see, these two lines, the fixed variable cost, this variable cost, and this line, which is the fixed cost, when I'm adding both of them, then I will get this new line, which is called total cost. So total cost is equal to fixed cost, which is this line, plus the variable cost, which is this line. So that's why we have total cost. That this is the total cost. Sometimes we have variable cost. So instead of using linear variable cost, there is a variable, not linear, a variable cost. And but for the fixed cost, there will be a fixed cost. This is also P. There will be a linear fixed to one term line. So total cost here also is equal to the addition of this variable cost plus the addition of the fixed cost. And then you will see, you can see there is a Lie curve. Here's the relation between the fixed cost and variable cost. So the objective of this lecture is to find the Q. Q is the production, how many units you needed to produce per unit of time, per day, per month, per year, to cover the cost. Here's the definition of the fixed cost: incurred regardless of the volume of to stay in business. That's what I said. we need to building of the cost of the building, the minimum labor of cost, and insurance, sometimes utilities, capital recovery of the equipment. These are called the fixed costs. They are fixed during the project and cannot be changed. So this is the fixed cost. The variable costs are varied with the level of the variable cost will be varied with the production. How much is the production? Usually it's contain material cost. As much as you have more production, as much as you need more materials and more laborers and more advertisements and warranty labels and so on. And now, what is the definition of break-even point? Break-even point can be found from this curve. This is the revenue. As you see, here's the unit costs. Here's the unit cost, and here's the, if I have, this is the revenue, this is the total cost. So in the beginning, as I said, you will not there will not be instant revenue while starting with any project, because you already paid for the for installment and for the investment that you have done for the land, for the buying materials, the buying machines. So there will not, there is no any, this is called the fixed cost. This is called the fixed cost. And after that there will be production. Well, the production, there will be revenue, and then also there will be a cost, which is called for the variable cost. And then in a point, there is a point that the money that you get from the production, selling the production, will be equal to what you get, you spend with the investment of this project. That's called the break-even point. So for this one, you have to be aware. After that production break-even point, everything after that, it will be in terms of revenue, and below the production there will be in terms of losing money. Now, profit. The definition of the profit is equal to revenue minus cost. So how much is the revenue? Let's say if I sell 1,000 units, 1,000 barrel, and so 1,000, and the price of 1,000 one barrel was $20. So $20,000 is the price, is the revenue. So, but the profit is, you have to be aware, the profit is not that 20,000. The profit is equal to how much is there, it was cost for that 1,000 barrel. So here's the real profit of this one. So revenue, it's the price, it's the total units that I sell, and the total cost etc. So revenue, we said if I have 1,000 barrel and per each one barrel, it was the price of each barrel was $20. So 20 times 1,000 will be the revenue. So R is the unit price. This is called unit price. A small r. That's why, because we have small, it means for 1 unit. Times Q. Q is the production. You will get the total revenue and the total monies that you sell. Variable cost, we said it's per 1 barrel's cost. So if for 1 barrel cost, I need to pay money for the laborers, I need to pay money for the land, taxes, and say that. So let's say for 1 barrel, I have to pay at least $5. So that 5, it's the unit price for the cost of 1 barrel. And Q is the 20, let's say 1,000 barrel that I sell. So the total money that was the price of the cost of that $1,000 is equal to 1,000 barrel. 1,000 times 5 is equal to $5,000 is the unit cost. This is a cost, a total cost, the total cost of the 1,000. The profit now is equal to $20,000 minus the $5,000, which is equal to 15. That's the meaning of the break-even quantity. So this is the profit. And if you want to know how much is the required amount of the production, so you have to make them equal, and then after that the term Q will be changed to Q break-even point. And here's the most important thing in this chapter. This is the equation. The equation, this is the dollar. We have fixed cost, and this is the unit price for selling the dollar per unit, and this is the unit cost for per unit. This is unit revenue price. This is the unit cost for each dollar per unit. So you will get the number of the produced materials that's needed to be on break-even point. For example, let's see this example. This is example 1. We have a monthly fixed cost per unit of water vending machine. So this is a fixed unit. The fixed unit, in example 1, there is a machine. Let's say this is a factory that's vending. There is a vending machine for water vending machine. This is the this machine needs $900 to be paid per month, and this is cost per site of the water. Sorry, this is per site. This is the fixed cost. So this is the per site. It should be paid for the machine of the water, vending water. This machine producing clean water, and the clean waters for gallons, which each gallon needs 18 cents as a cost per 1 gallon, and you can buy 1 gallon by 14 cents. Now for this machine you need to pay $900. That's the cost per site. So whenever there is a production or not, you have to pay $900. And the production of this machine is gallon pure water. And pure water, there will be this is gallon of all clean water. 1 gallon of clean water will cost at least 18 cents, 18 cents. And then you have to buy, or you can buy 1 gallon of this clean water, purified water, by 30 cents. Now we have monthly. We need to know how much monthly required to sell pure water gallons to cover the $900 only, and this is called the break-even point. To solve this one, so we need so as I say, 1 barrel, this is the machine, and the machine costs $900 per month. This is per site, and this is gallon, pure gallon, pure water gallon. Cost 1 gallon will cost 18 cents and can be buy, this is cost, and can be buy by 13 cents as a revenue. So the required is Q. How much is the Q required just to cover the $900 the price, and this is called break even. This is called break even point. Solution based on the rule, we say that Q break even point is equal to the fixed cost and revenue small r, unit price for the revenue minus unit price of the varied cost, which is small v. Now fixed cost is the unit, the $900 per month, and revenue is the price of one produced gallon in the bazaar or in the markets. So it can be sold for 30 cents or $0.3 per 1 unit. I mean 1 gallon. Okay, per 1 gallon we need to spend 18 cents as a labor and electricity and maybe, so it means 0.18 is the required to produce 1 gallon as a varied cost. Now as a result it's equal to $900 per month divided by 0.3 minus 0.18. This is dollars per unit. So the answer is $900 divided by 0.3 minus 0.18. The answer is $7,500 as a unit per month. You need to sell you need to sell $7,500 each month just only to cover the $900 that was the fixed cost, and this is after the $7,500. This can be said this is the profit. So this is the price of 30 cents or $13.3 or 30 cents. Now it's a critical price. If you need more, you have to pay. If you need more benefits, you have to make the price of 1 gallon more than $3.3. Yeah, so as you can see, here's the 7,500 unit that's required. I'm sorry. Just to cover, this is gallon or unit per site. It needs just to cover the cost of the $900. Through this example, we can draw this line. So this line, here's the line, is the line of the revenue. We will start from zero when you don't have any production, but you have to pay $900. This is the $900 when it's a fixed, and per 1 gallon produced you need 18 cents. So here's the from line of the total cost, which is equal to variable cost plus fixed cost, and the variable cost, this is equal to V small v times Q. Now as you can see here from this graph, the slope of this line. Here's the slope. When we are the slope of this line one can be lowered, it will be here. Lowering the slope of this line will means making small v less. It means you need to make the cost per one production to be less than 18 cents. So the less than 18 cents, so the total cost is equal to small v times q plus fixed cost. So this will be small, and when you are smaller, it means the slope will become down. Now you can see here's the break-even point. It was here. When you slope here, then you have, this is the range of interest that we have. So making or lowering the slope of the total cost line, it means that we are in the profit region more than the previous. So here's the result. Lowering slope, it means the total cost line has a lower slope, and then we have break-even point. So break-even point become smaller. So instead of $7,500, you may need 6,000. I don't know, but it means that you are going to have a more area region for profit. And if you have a nonlinear area, the same will be done for you. Let's solve the same example while we are going to lower. This is the price. I'm going to lowering the unit price or the unit cost price. So how much it was needed for producing 1 gallon of water? It was 18 cents. For this one, maybe the owner or someone else who have the machine will work on making the cost materials, using another materials, bringing some laborers that work with the lower price. So instead of 18 cents, it needs 15 cents per 1 gallon. So let's check the profit now. The same solution, we say that we have $900 per site per month for the fixed cost. This is called the fixed cost. And for break-even point, we need to know $900 per month divided by it was the price of 1 gallon. It was 13 cents, $0.3 minus now it cost one gallon. It cost 15. That's my study. If I'm going to lower the 18 cents to 15, so let me check. This is unit. This is dollar per unit. So let me how much I need per month to cover the cost of the $900. So divided by 0.15. So yes, we need only 6,000 to produce unit per month, just only to cover the cost of the cost of what? The cost of the $900. So here's the price. Now if this is $6,000 units is just enough to cover. Now more than this one, we have $8,000 production. So the profit can be said is equal to the $8,000. This is 8,000 units minus 6,000 units. That's the variable, or that's the limit that we have passed the break-even point times. In each gallon there is a revenue. The revenue is $0.3 minus $0.15. This is the price, market price. This is the varied cost, and the result is equal to $2,000 times 0.15, which is equal to $300. So $300 per month will be the profit. So the profit now we have, when we produce and sell $6,000, then there will be zero profit. But we have sold $8,000. We covered the cost of the machine within the 6,000 unit production, and after that, beyond that, there will be the profit, and the profit is to 2,000 more the extra 2,000 units production, and each gallon of these 2,000 units will have a profit of 0.3 minus 0.15. So as a result, we have $300 per revenue per this project. Okay. Sensitivity. Now we discussed the price and how can it will be and how's the production. So lowering the variable cost, or lowering the total cost, or increasing the price will give you more profit. Sometimes there is some factors will not affect that kind of profit in terms of engineering economy, and there is others will affect directly this process, and varying, let's say here, increasing or lowering the price from 18 cents to 15, which means 3 cents, will give you just 3 cents will give you a profit of $300. So 3 cents by $300. This is a sensitivity. So we can say, yes, the unit price is sensitive. It's a variable that will be affected directly to this cost. This is the way. And how can we have there is a parameters for one parameters for single project. Sometimes you have this, I'm talking on one project. There maybe you have more than one project and one alternative. Maybe sometimes you have several parameters and single project. You have to analyze and find the parameters that will be sensitive to this project. Here's some parameters of variation cost more sensitive than the others. So as an engineering, you have to be aware that the salvage value will give you a little effect after 20 years life, because after 20 years of the project the salvage value will going to be less than or approaching zero. So it means that there will not be that affected, and the 20 years is enough to decrease the amount of the money. Revenue per unit have a major change in break-even quantity. The revenue per unit. The revenue per unit, it means if in the same example, in the previous example, if you go and if you sell the 1 gallon of water instead of 30 by 35 cents, so you will get a very large, or let's say it will be affect directly on the break-even point. Sometimes we have to be aware that capital recovery and in each year will be would be an effect, less effect, and minimum attractive return rate here not effect, because usually in the break-even analysis we are not talking about the I. So there is no time varied analysis. General procedures for sensitivity analysis. First of all, we have to determine the parameters that might vary and can be varied and can be interested. The second one, we have the probable range, and the third one, the measuring and the worth, and computing the measure of the worth of each parameter, and lastly is the inferring the results by plotting the parameters via diagram. So diagram is a very important thing to know. And look at this example. In this example 3, I can show it to you how to do it. Okay, so we'll come back. Here we can say in example 3, for the following data, determine the impact of the present worth. This is the present worth at I equal to 15%, P is equal to $800,000, and N is equal to 10. The salvage value is equal to 0. So revenue estimates as $250,000 per year, and will be decreased every year. Now, if I'm instructing or drawing the cash flow diagram of this program or this equation, here's the first payment that's needed to work with this project. It was $800,000, and the N is equal to 0, 1, 2, 3, 4, 12, 10. And the first year, every year, it was $250,000. This is the revenue, but this revenue will be decreased every year by a certain amount. There is a certain amount. This certain amount is called G. The G is the certain amount. It was most likely $20,000. So the second year it was $230,000. The third year it was $210,000. Now you can see there is a revenue, and the revenue will be decreased. There is a variable here, and there is another one, and there is I, we have 15. I want to know whether this decreasing, this value, this G will affect or will be sensitive. This project will be sensitive. There is a sensitivity to work with this project with the value of G or not. Now, so this is one single project, and with one parameter, the parameter is G, and I want to check whether G is sensitive or not. So for this one solution, I want to first of all, the variable that I have G, we have $20,000 every year will be decreased. I will add another two values to check. I will use another G, the G is equal to, let's say, 20. I will use $25,000, and I will use another value of G, let's say it's equal to $15,000. That's, I want to use another two values of G's to draw, because how can we say that value of G will be sensitive to present worth or not? I have to draw the line which is called the present worth, and sorry, this is the N, this is the present worth value. I have to draw the lines, and this line will express the present worth value. This is via G is equal to 20, and I will have another one with this present worth value within G is equal to 15, and within G equal to 25. So I will compare between these three lines slopes. If there was a slightly sloped line, this means this parameter, the value of G's parameter, is not sensitive. If you have a sharp parameter, the sharp parameters, it means the and this value of G is sensitive to this prison worth analysis. So first of all, we have to count to find the prison worth value. Okay. So prison worth value for this one is equal to minus $800,000. This is the unit cost, and plus this is cost. It should be negative. Plus we have $250,000. This is A. If I consider this one as an A, because I will consider this is A. So 200,000, that is A. I want to make it as a P for N equal to 10, I equal to 15. Minus, why minus? Because every year there will be a change. A change is in terms of G, and this G gonna be P for N equal to 10, I equal to 15. This is the main equation line. So one, I have to use this equation, or I have to draw a line between the prison worth and the G value. I will try G 25,000, 20,000, and 15,000, because I want to know for each one how much it will be the prison worth. And then after that I will draw between the G prison worth value and G. Then I will see is there a hard or sharp slope. Then the sharp slope means the value of G is sensitive to this project. If there was not there was a flat, this is visually, if there was a flat slope like this, it means the value of G is not that affect, or it's not sensitive to this project. So we will use first of all add G equal to 25,000, and exactly in 25 we will find the prison worth as in this. 3, because only 3 points is enough. After using G is equal to 20, there will be the value of the prison worth is 115. After using G is equal to 25 and 15. Why the variation is in terms of thousands? So because we have 20, the ideal one is 20, so I will make more in terms of thousand, making less in terms of thousand to get the values. Now I will draw the lines. Here's the lines. So this is in G equal to 15. This is the value of the prison worth, which is equal to 20,000. When we have G is equal to 20,000, the value of is equal to 115, and we have 20, and this is in terms of what, 30. So you can see there is a sharp slope. Sharp slope, it means the yes, G is sensitive or has a sensitivity to use in terms of this project. Yes, so the answer prison worth, the sentences should be written like this. The prison worth is sensitive to variation in G. Variation in G will give a sensitivity of the P. Sometimes we have more than one parameters, like not only the G, we have more than one parameters. Then you have to draw all of them in one graph and to see. For example, an engineer has performed an economic analysis of 12 months, and the results were plotted in a so-called spider graph. Spider graph, it is you have more than one curve in one graph, and the graph is given to you. We need to know whether which one is a sensitive parameters or not. So this is given to you. This graph is given to you. This is made by this engineer, and I want you to tell me which one is sensitive, which one are parameters. So as you can see, here's the sale price. The sale price of this project will give you a variation from the estimate. So you can see there is a high sharp slope. This is sharp slope. So sharp slope, it means yes, this is sensitive, has a sensitivity. Also we have positive one. This is the positive one. Material cost also give a sharp slope. Sharp slope, it means this is also there's also both of them, the material and the sale price are they are sensitive, and the other two one are relatively, they are flatted slab, so flatted slope, not slab. So we have labor and the maintenance costs are not affecting that much. That's cost will be varied, and that's, we can say they are relatively not sensitive to this project. And yes, here's the non-sensitive ones are the labors and the maintenance costs, and the sensitive tools are the material cost and the Spiderman. This is another one, payback period or payback analysis, PBNP, number of the periods required for covering the cost or to recover the amount. We say the best pricing strategy can be founded by using the break-even point, how much units production sales you need to cover the cost. But in terms of periods, we need to know how in this production should be in how many years, how many periods, how many months. That's called the payback time. So payback time or payback analysis will give you the period that's required to recover the investment. We have two types of payback analysis. One in terms of that when we have zero interest rate, and when we have more than zero, or let's say greater than zero return rate analysis. Interest rate. And here's the equation. So we are going to use to find n. So NP is the number of the years required. We have the payments, the invested cost, and we have the cash flow diagram, net cash flow diagram, and then from I time equal to 1 year till to I don't know. So here's how to find this one. From this equation we can find the number of the periods required to find the years. Let me give you this example. In this example, in this example, as you can see, we have find payback or number of the period, NP. We don't know how much in the N of a P that needs to cover the cost of the project, which was $18 million. So $18 million it's what's required for this project. And this project, from the beginning till year 5, there was not any revenue. But after 5 years, there was a uniform revenue, and the uniform was every year it was $6 million. So how can I solve this one? Let's work with the first one. The first one, when I equal to 10% return money. So the work will be to find, first of all, the present worth of this cash flow diagram. So from beginning, there's a P equal to 18. Here's the P equal to 18. Yeah, this is 18 because I'm going to find this is the P is equal to 18. And for the first 5 years there is, so from 0 to 5 years there is no any revenue. From the 5 years, 6 years, 7 years till end period years, there is a uniform $6 million payment. So I have 6 million per year. It's gonna be P, and the P it will become here. And then after that, after it became a P, a value of T, so the procedure is to find a uniform payment, make the annual payments as a uniform. Then after that there will be a 5 years return. That F will become P. So let me do it for you. Now this is year 5. We have 1, 2, 3, 4. I don't know. We have 6 million every year payment. So what I am going to do is to converting all these values to a single value. It means that you have A, you need to make it as a P. For n equal to n period and I equal to 10%. So this is now we have done with the all payments. So here's the 6 millions P A become P for X years. X years means number of the period. Now after that, so forget about this part and come to this part. After that we have 18 million. Here's 18 million. We have F value. We have this value which is equal to this value. I want to convert it to make it as a F. So this is F, make it as a P for n equal to 10 and n equal 5, I equal to 10. So as you can see, here's one equation. This one equation, we have only one unknown, and this one unknown is the number of the period can be solved using the trial and error, or using the Excel sheet, or you can use the tables to find the number of the years that's required to cover the 6 million payment. So as you can see, the result we get X equal to 7 years. So I need 7 years, and 7 years every year times 6 million, it means 42 millions. 42 millions is needed only to cover 18 million. So yes, of course you have 42 millions more than the 18, but this is times money. This is the times, because you already paid 13 years before. You paid 13 years before 18 millions. That means the 18, like you are going to invest your money in a project, and you can get the values after 13 years. So okay, so 5 years earlier and 7 years here, we need, so 12 years is the number of the years that's required to recover only the 18 million. And what if there is no interest rate, there is I equal to 0? In this way, yes, if I have I equal to 0, that means we have 18 millions, and after 5 years we have every year's 5. We have every year 6 millions. So 18 divided by 6 means you have 3 years. You need 3 years to recover the whole 18 millions. 3 years plus 5 years, so 3 plus 5, 8 years needed period to cover the whole 18 millions. That's called the payback analysis. Finally, I hope you understood this lecture very well, and please try to read the lecture notes and try to study. And if you have any question, please don't miss to ask me, and I will answer you. Thank you for listening, and happy day, and see you next time. Bye bye.